Hello guys, I am Molly from IAR College, Mechanical Engineering. I want to give my presentation now. Homogeneous boundary value problem, mathematical foundations. Homogeneous boundary values problems, mathematical generation. A homogeneous boundary value uh, problem is a differential equation or system of equation combined by the boundary conditions where the prescription conditions are set to zero. These problems arise in various areas of mathematical and physical, particularly in partial different equation and ordinary differential equations. Below, we explore their mathematical foundations in detail. Introduction to boundary value problems. Boundary values involve finding solutions to differential equations that satisfy given boundary conditions. Unlike initial value problems, which specify conditions at a single point, BVPS imposes conditions at multiple points. Homogeneous and non-homogeneous is one where all boundaries conditions are zero. Mathematically, this means if the differential equation is given L into y is equal to 0, where L is a linear differential operator, the boundary conditions take the form. For non-homogeneous, the boundary conditions involve non-zero functions. And the next one is linear operations and eigenvalue problems. Homogeneous BVPS are closely related to eigenvalues problems. A differential operator L applied to a function y into x yields an eigenvalue problems, where representations and eigenvalue solution exists for specific value of known as eigenvalues with corresponding eigenvalue functions. And the next one is Sturm-Liouville problem. A classically example of homogeneous BVP is the Sturm-Liouville problems formulated as with homogeneous boundary conditions. Such problems are fundamentally in solving PDES VIA separation of variables. And the next one is adjancents and unique of solutions. For many homogeneous uniques of solutions, for many in the extensions unique theorem guarantees solution under certain conditions. The Friedholm alternative states that solutions exist if and only if the associated homogeneous problems has only the trivial solutions. And the next one is Green's functions. A powerful method to analyze homogeneous BVPs is through Green's functions, which help presentation solution in integral form. This approach is useful for solving linear differential equations subject to boundary constraints. Separations of invariables. One of the most common techniques for solving homogeneous BVPS is separation of variables, which decomposes a PDE into simpler ODS. This method is extensively used in heat conditions, wave propagation, and Laplace's equations. And the next one is Fourier series and eigenfunction expanses. Homogeneous BVPS often have solutions that can be expressed as infinity series expansions in terms of orthogonal eigenfunctions, particularly Fourier series. Where are eigenfunctions of a differential operations? And the next one is applications in physical and engineering. Homogeneous BVPS plays a critical role in physical and engineering, including vibrating of string. Describe the way equation with homogeneous Dirichlet boundary conditions. And second point is heat condition solved using separations of variable in the heat equations. Electromagnetic waves. Solution to Maxwell's equation with homogeneous boundary constraints. Quantum mechanics. Solving the Schrödinger equation under potential constraints. In the next point, fluid dynamics governing equation of incomprehensible flow often involve homogeneous boundary conditions. And the next one is numerical methods. In practically scenarios, exact solution to homogeneous BVPS may not be flexible, necessitating numerical techniques such as finite difference method (FDM), finite eliminate method (FEM), and the last one is spectral methods. And the next point is functional analysis perspective. Homogeneous Homogeneous BVPS can be studied using functional analyzing where solutions belong to function spaces such as hybrided spaces, concepts like orthonormal basis, self-adjoint operations, and weak solutions are crucial in these approaches. And the next point is boundary layer theorem. In fluid mechanics and applied mathematics, boundary layer theorem helps understand solutions of BUPS where then expressions rapid changes requirement actions analysis techniques. And the next one is nonlinear extensions. While the discussion focus on the linear homogeneous BUPS, nonlinear versions also exist methods such as perturbed theory, variational methods, and bifunctional analysis extend to nonlinear problems. And the next one is connections to topology. Homogeneous BVPS also appear in topology and geometry, where differential equations describe geometric structures, harmonics, functions, and spectral properties of mathematics. Energy methods. Energy principles are commonly applied in solving BVPS, where functionals representing energy are minimized to obtained solutions. Variations method. Many BVPS can formulated in terms of variations principles, where solutions satisfy minimalization properties of functionals. Homogeneous theory. Homogeneous BVPS are crucial in homogeneous theory, which deals with material having periodic structures and their Marconics properties. Perturbation methods. Perturbation methods analyzes how small changes in parameters affect a solution, useful for understanding stability and sensitivity in homogeneous BVPS. And the next one is spectral methods in homogeneous BVPS. Spectral methods use eigenfunctions expenses to approximate solution, leading to efficiency confirmation schemes, optimal controls, and BVPS. Homogeneous BVPS play a role in optimal controls theory, where boundary conditions describe optimal trajectories in dynamically system. And the next one is additional topics in homogeneous BVPS. Oh, to ensure exactly 50 in homogeneous mathematically software for solving BVPS, higher order BVPS directly versus Newini boundary conditions, green functions for different PDES applications in modern technology in artificial intelligence, and the last eigenvalues, numerical methods completed, and the last PDF of my slide is conclusion. Homogeneous boundary values problems are fundamentally in mathematical, physical engineering, and applied mathematics. The analysis involves in angle values, green functions, and various numerical methods, making these them as essential tools for solving complex differential equations with deeper theoretically and numerical advancement. These problems continue to be at the forefront of scientific research and applications. And this is my presentation. Thank you for watching. Thank you.